Hello and welcome to Spring 1 Week 5 exam on fighting disease with drugs. Little reminder, you're going to need your green pen with you for marking your answers and your blue pens for a few annotations. Right, let's get started. So, first question says, some antibiotics work by destroying the cell membranes of bacteria. I've just made a little note for myself that antibiotics only destroy bacteria. They're not going to be destroying a viral or fungal pathogens. Suggest why these antibiotics may have side effects in animals that are given these antibiotics. The key part to remember here is that the antibiotics destroy cell membranes of bacteria, and animal cells also have cell membranes, and so animal cells could be harmed by antibiotics. Right, each arrow on the figure below shows the date of discovery of each new type of antibiotic. In which 10-year period were the most new types of antibiotic discovered? So you're looking for 10 years where you got the most antibiotics being discovered, and this was a bit of a fiddly question where you had to try a couple of different 10-year periods and count the number of antibiotics being discovered. The answer was 1945 to 1955. You could have also said 1946 to 56 or 1947 to 57 for your mark. So we're thinking about this time period here. The figure above shows 22 new types of antibiotic. These were discovered before 2010. Determine the percentage of types of antibiotics that have been discovered between 1980 and 2010. Use information from the figure above, giving you answer to two significant figures. So, if I have a look between 1980 and 2010, only 2 antibiotics were discovered in that time period. So, I'm going to do 2, divide by the total number, 22, multiply it by 100 because I'm trying to calculate a percentage. That comes out at 9.090909 and so on, so 09 recurring. When I round that to two significant figures, it comes out at 9.1%. 2 marks for that. Question 2. In 2014 there was an outbreak of Ebola virus disease, EVD, in Africa. You might remember it on the news. Just made a little note for myself that as it's a virus disease, I think about it being a viral pathogen. At the time of the outbreak, there were no drugs to treat the disease, no vaccines to prevent the infection. By March 2015, there was an estimated 9,850 deaths worldwide from Ebola virus disease. The number of deaths is only an estimate though. And the question is asking us to suggest why it's an estimate rather than the exact number of people who died from this disease. A couple of reasons for this. You could have said that not all the deaths were recorded, so some people might have died and their death wasn't recorded. Possibly people who die in, say, like rural villages, and there isn't the same kind of record collection as in urban areas. And a similar kind of answer that not all causes of death are known, so someone might have died but we weren't too sure if they died of Ebola virus disease, or maybe their death, the cause of the death wasn't recorded. Either of those for 1 mark. 2b. Why were no antibiotics used to treat EVD? Remember, EVD is a viral pathogen and antibiotics do not kill viruses. You could have said antibiotics only work on bacteria. That would have been fine for your mark. 2c. After the outbreak began, drug companies started to develop drugs and vaccines for EVD. A drug has to be thoroughly tested and trialled before it is licensed for use. Testing, trialling and licensing new drugs usually takes several years. Draw one line from the word about drug testing to the definition of the word. Okay, so here's what your line should look like. Dose is the concentration of the drug to be used and how often the drug should be given. Efficacy, whether the drug works to treat the illness, and toxicity are the side effects on the person. You get 2 marks for getting those lines correct. If you've got one line in the wrong place, you get 1 mark. The result of drug tested and drug trials are studied in detail by other scientists. Only then can the results be published by the drug company. Suggest one reason why the results are studied by other scientists. Think about you're developing a new drug. When you get the results, you need to get someone else to check it. Why might that be? One is to prevent false claims. Obviously, lots of these scientists want to shout out, I've cured cancer, but they possibly haven't. We need to get their studies checked by other scientists, because otherwise they can make these false claims and possibly make lots of money off of their drugs. Again, a very similar answer you could have said to make sure the conclusions are correct or the conclusions are valid. So from the data that they found, is what they're saying actually true? And to avoid bias, some of that unfairness. Maybe the scientist really wants to find the cure for that drug, for that disease, pardon me, and so they might be biased in that way, so it needs to be checked by another scientist. Any one of those for 1 mark. Question 3. Scientists at a drug company developed a new pain-killing drug, which we're just going to call drug X. Painkillers do not cure infectious disease. Asking us why? Because the painkillers do not kill pathogens. You could say they don't kill bacteria, they don't kill viruses. Or you could have said they only treat the symptoms of the disease. Either of those for your 1 mark. The scientists compared drug X with 2 other pain-killing drugs, drug A and drug B. In their investigation, the scientists chose 600 volunteers, and all of these volunteers were in pain. That's why they volunteered for this trial. They gave 200 of the volunteers a dose of A, 200 B, 200 X. Okay? Over the next 7 hours, the volunteers recorded how much pain they felt. To get valid results, the 3 groups of volunteers should be matched for as many factors as possible. So really, think about any kind of experiment, you want to change your independent variable, measure the dependent variable, and then we've got those control variables that we want to keep the same. And it's the same in these drug trials. They're changing the drugs that they're giving to people, they're measuring how much pain they felt, but everything else they want to keep the same, including factors about the people. So, 2 factors that should be matched. Any 2 of these are things that are tried to match up within the groups, try to keep these the same. So the age of the people, the gender of the people, the amount of pain they felt before the trial, or the type of pain they felt before the trial, the mass, the weight or the height of the people, their overall fitness, or their ethnicity. All of these things could affect how they experience pain, and so you'd want to try and keep them the same within your groups. 2 of those for your 2 marks. Okay, the graph shows the results of the investigation. We've got the mean percentage decrease in pain. That's really important when paying attention to that. And the time in hours after taking the drug. Okay, we see we've got 3 lines, one for drug X, one for drug B, one for drug A. I've made a few annotations on my graph of just initial things I thought when I saw this graph. So if we look, as soon as the drugs are taken, both drug X and drug A are much faster to relieve pain. See, they're working much quicker, they're relieving more pain in a short period of time. But drug B and drug X are much longer lasting pain relief. You can see here, that line is staying higher up for longer, and they give greater pain relief overall as well. You can see the peak amount of pain relief they give is much higher than it is for drug A. So those are just some initial thoughts I noted down when I saw this graph. How much pain did the volunteers still feel 4 hours after taking drug A? So we're looking at drug A here, I'm reading off my graph, you can see my dotted line that I've drawn. Going to 4 hours to drug A, reading across, and it comes to 25%. Now remember, that's a 25% decrease in pain. If you think about it, we're starting at 100% amount of pain that they feel. If it's decreased by 25%, then the answer is they still feel 75% of their pain. 3CII. Give one advantage of taking drug A, which remember was this line on the graph, and not of taking drug B. And this is where my annotations come in to really help me. I've already said that A and X are faster to relieve pain. So I could say this, it's faster for pain relief, or that it works quicker. You see I've underlined ER here because it needs to be a comparison, a comparative answer. Okay, so you need to be saying that A is faster or works quicker than B. If you didn't say that, if you just said fast pain relief or works quickly, you can't have your mark. Okay, 2 advantages of taking drug B and not drug A, and again my annotations come in to help me here that I made earlier, that B lasted for longer and there was the greater pain relief as well. And that's exactly my answer to this question. Higher or greater pain relief, longer lasting pain relief. And again, I need to be making a comparison in my answer. 3D. Drug X is much more expensive than both drug A and drug B. A pharmacist advised a customer that it would be just as good to take drug A and drug B together instead of drug X. Right, so we can save some money by taking these two drugs together. Do you agree with the pharmacist's advice? Give reasons for your answer. You don't get any marks for saying yes, you don't get any marks for saying no. You could say either, that doesn't give you any marks. Your marks are for your reasons. So if you said yes, these are reasons you could have said. So you need 3 of these to get 3 marks. You could have said that you'd get rapid pain relief from A, you'd get the long-lasting relief from B, so those two together would come up with similar effects as X. This would cost less than taking drug X, and A and B together might have a greater effect than X, possibly. We don't know. Okay, so 3 of those 4 reasons for your 3 marks, if you said yes. If you said no, these were the reasons you could have given. You could have said that X gives more pain relief overall. If we have a look on the graph, X's peak here is almost relieves close to 100% of pain. A and B could interact with each other. What this means is when you take different drugs together, we don't know whether they might have an effect on each other, and that could cause problems, that could have effects that we don't understand. So that could be a reason against taking this pharmacist's advice. It could result in an overdose, taking 2 drugs together, and there could be possible side effects that we don't know about as well. So these are all reasons not to follow that pharmacist's advice. Again, 3 of those for your 3 marks. Okay, question 4. New drugs have to be tested before they can be sold. The graph shows how much time the different stages of testing took for a new drug. Right, and I've annotated how long each of these stages lasts. Okay, so 4 years, 2 years, 3 years, 4 years, 1 year. How much time did the laboratory testing of the drug take? Well, this is where my annotations come in helpful. Already worked it out for laboratory testing. That's 4 years, 1 mark. Suggest what the drug was tested on during laboratory testing. Remember, laboratory testing we sometimes call pre-clinical trials. Okay, and these preclinical trials are the ones before we get to clinical trials, which is where we test on human beings. So here you could test on cells, you can test on tissues, or you can test on animals. If you'd named an animal that was reasonable, such as a mouse or a rat, you could have that mark. Okay, cells, tissues, or animals for a mark. Then clinical trials are carried out on human volunteers and patients. How much time did the clinical trials take for this drug? So we're looking at our clinical trials. We've got 3 different phases taking different times. So I'm going to add up those times. 2 plus 3 plus 4 equals 9 years. You get 2 marks for getting that correct. If you got 2 plus 3 plus 4 and then got the answer wrong, you can still have a mark. Okay, but we should know how to do 2 plus 3 plus 4. Okay, 4BII. Apart from the time taken, what other difference is there between laboratory testing and clinical trials? So apart from the time taken, look for another difference. We've already said it in the question above, that in the laboratory testing, we test on cells, tissues, or animals. In the clinical trials, we are testing on humans. That difference for 1 mark. Okay. During phase 1 clinical trials, the drug is tested on healthy volunteers using low doses. Suggest why only healthy volunteers and only low doses are used at this stage of drug testing. Okay, so the reason we test on healthy volunteers is because the risk could be too high for someone who's already ill, they're already suffering, they're already unhealthy. Possibly putting a new drug that we don't know about into their body could be too much. Also, it's much easier to see side effects on a healthy person as well. If someone's already ill and then they start to get worse, we don't know if that's a side effect of the drug or of the disease that they already have. The reason we have low doses is to reduce the risk. We don't know how dangerous this new drug might be, and so we don't want to put too much in. And also, again, to look for those side effects. 2 marks, so 1 mark comes from here. 1 mark comes from here, right? You need 1 of these for 1 mark, one of these for 1 mark. In phase 2 and phase 3 clinical trials, a double-blind trial is usually done. The question wants us to explain what a double-blind trial is and why a double-blind trial is good practice. So, first of all, get 1 mark for saying, in a double-blind trial, we test both a placebo and the actual drug. Okay, so there's 2 groups, one being given the placebo, one given the actual drug. 1 mark. Another mark for saying that neither the patients nor the doctors know. So you need to say both of these groups of people don't know who is getting the placebo and who is getting the actual drug. So that's 2 marks there. Your last mark is for saying why a double-blind trial is good practice. 3 possible answers you could give here. You could have said to avoid bias, to control for psychological effects, so someone thinking maybe they're getting better when they're not. And similarly, the answer here, you can tell if the drug works rather than the placebo effect. So remember, the placebo effect is when you give someone that placebo and then they think they're getting better when actually they're not. Okay, and that can sometimes look like the drug is working when it's actually not. So that's the placebo effect. 1 of these marks for your 3rd mark in this question. Remember to go back to the beginning of your exam now and writing your final mark out of 29.